Welcome to Train Signal. You're watching a lesson on routing. Yes, you heard me correctly, routing. This is a term that you've heard me mention throughout the course in many different lessons, unless, of course, you jumped right to this one first. But whether we were talking about hardware and we were talking about routers, or maybe we were talking about TCP/IP and how routing works with it, well, this is the lesson that I kept talking about when I said, oh, we'll learn about routing. So you want to learn about routing? Here it is. So the first thing that we need to discuss when it comes to understanding routing is understanding the idea of routing tables. Now, a routing table is something that is used by all network devices, okay, not just routers. And actually, I'm going to show you in just a moment here, even just a regular client computer will have a routing table. And the reason why is because any network device needs this routing table in order to determine where to send a packet to when it's attempting to get it out and routed out to its final destination. Okay, so when a computer or a router or any other network device has a packet of information and it knows what IP address it wants to eventually get it to, it has to look at a routing table to know what to do with that packet. Now, one thing that might make this a little bit more clear is I would like to take you over to a computer that I have here, and let's look at the routing table. And I will tell you, in order to do this, we are going to look at the route command, because the route command is what Windows operating systems use to display and modify the routing table. Okay, so here we are on my desktop. And if we're going to look at the route command, well, we need to go to a command prompt. And we do that by clicking on Start. And as I've shown in other lessons, you may find it already pinned onto the Start menu if you've been to it recently. Or you can get to it by going to All Programs and then Accessories. But I like to just simply type CMD into the search box, and then there's the command prompt. Once in the command prompt window, you'll see here that we can type route and then /, which will show us all the different help with this command. Now let me scroll up a little bit through some of the help here. You'll notice that there is quite a bit. There are some switches, not very many. There's just the 4 of them here. And these switches only will do something if you've also done a command with the route command. Okay, that's one thing to keep in mind, is that route by itself is not typically used. Okay, so let's take a look at this. You'll see here -F is for clearing the routing table of all gateway entries. -P, this is actually a really important one if you're working within a Windows operating system and you want to manually modify the routing table on that computer, and you want that entry that you add to the table, let's say, to stay permanently, or the P actually technically stands for persistently, then you have to use this switch. Otherwise, any entries that you make will disappear as soon as the computer is rebooted. Then you see there's -4 and -6, which has to do with forcing IPv4 or IPv6. So here's the deal. If I scroll down a little bit, you'll see here that there is one of these commands, right? It says command, one of these. Print, add, delete, and change. Okay, so these are the 4 commands that you really use with the route command. And if this is confusing, don't worry, I'm going to show you in just a moment. But basically, you have commands like route print. Okay, you put it together to make a command. Route add, route delete, and route change. Then you can go ahead and do one of these switches as it applies to the individual command. Now let's take a look at some of these commands. Let's start off with route print. Okay, so I'm going to actually just type in route space print. And you'll see that you get the routing table printed, but not to a printer. It gets printed onto the screen. Okay, so let me scroll up a little bit here. And you'll see, let me go all the way up to where you can see I typed route print. Here you have the IPv4 route table. And if I scroll down, you have the IPv6 route table. Now, I will tell you for right now, I want you to pay attention to the IPv4 route table. Both tables work similarly But for the sake of learning this command, for most people, they find it easier to do so in the IPv4 environment. So let's take a look at it. If we look at this table, you'll see that we have a number of different columns here, right? We have network destination, which is just that, meaning the computer will, when it's sending a packet, it will see which destination it falls into. And we'll talk about how it can fall into more than one destination in just a moment here. Now, another way that it knows if it's part of the appropriate network destination has to do with the net mask. Net mask stands for basically subnet mask. So when we're looking at these different destinations, so I'm going to pick this one right here in the middle where it says 192.168.10.0. You have to put on the subnet mask of 255.255.255.0 to illustrate that the network destination is the 192.168.10 network that it's referring to. Whereas if you have something like the next line, which says 192.168.10.100, and the net mask is 255.255.255.255, that means it's being very specific if the destination is that full IP address. Okay, so that's kind of how it looks at it. Just like with an IP address where it has to have a subnet mask, our network destination has to have a net mask. Next, we have the gateway column. And what the gateway column says is, all right, if we've determined that the packet is being sent to one of these network destinations, right, we've determined this is the destination where we're sending the packet, where do we send it to? And when you see on link, that means, oh, okay, I'm sending it to a destination that's on my network that I'm connected to, and I can just send it directly to that destination. And if it's not on your network, then it's going to give you the IP address of a router that you're going to send the packet to. And then the router will then forward it on to the appropriate network. Now you'll notice that this particular routing table, there's a couple things I need to point out. Number one, this is just a regular old computer. Okay, this is not a router. Okay, this is just a regular old computer. It has one network card, so it's not doing any routing of any kind. But yet it still has a routing table because all systems do. If you had to take a guess why all of these various entries are in here and they all say on link, except for one, well, that's because these are all the default built-in entries that you're going to have just based upon having an active network card. And this very top entry that says 00000000, that is your default gateway. Okay, so when we configured TCP/IP on this computer, we put in a default gateway of 192.168.10.1, and that's why it's listed with this entry of all zeros right here. That's the entry for default gateway, meaning it's the catch-all. If I have something that needs to get somewhere and I don't have any idea who I'm supposed to send it to, boom, I send it to my default gateway. Now the fourth column here says interface, and this has to do with what network card or what interface am I going to be sending the packet out. All right, now this, again, if we had a computer that has more than one interface, right, if we had more than one network card, then you would see different entries here. But you'll notice that because I only have one network card, the interface is going to always be the same. Now you notice there are two different entries, but they are representing the same thing. 192.168.10.100 is the one network card and the one IP address that I have assigned to that card. 127.0.0.1 is the loopback address, meaning I send it to myself. Either way, they both represent the same thing. The last column is metric, and this has to do with in the event that the destination that you're looking to send a particular packet off to is a part of more than one network destination, meaning it obviously can only be one actual network destination. But on this table, it's listed twice. It will then determine which route to pick based upon the metric, meaning which one is theoretically faster or cheaper as far as routes go. So now, I don't want you to be too overwhelmed with this. This is just real basic. I just want you to understand what the 5 columns are. Again, don't worry about this routing table too much because, again, we're not looking at a router or anything. We're just looking at a regular computer because I wanted to show you that a regular computer has all of these entries. And to maybe make this a little bit more clear, how about we do another route command? Let's do the route add command. Now, if I scroll up, and I'm just going to scroll up through my command prompt here, back up to the help, you'll notice that when you do something like some of these commands, like the add command is a really good example, you then need a series of entries that will follow, right? You have destination, which will be the destination that you're sending it to, or as far as the network ID that you're looking to create. Mask is going to signify, or as they say here, specify, that the next parameter is going to be your net mask. And then net mask, of course, is your subnet mask. Gateway would be the specified gateway that you want to send it to. Interface is if you want to tell it to go out a specific network card, although I will tell you that that one is not necessary because it will be assumed based upon the gateway that you pick, unless that gateway can be accessed via more than one card. And then metric, again, it's optional only if you want to put a specific metric entry, knowing that there's more than one route. So let's see how this all gets put together. I'm going to put in route add, and I'm just going to make up a fictional network that I want to connect to. We're going to say 192.168.11.0, right? So that's a network, space. I have to put my mask, so I actually put the word mask to tell it that I'm going to put a subnet mask, space 255.255.255.0. And then the only other thing I need is I need a gateway. So I put in a space and then the IP address of the router that's going to get me to that network. Now again, I have a default gateway of 192.168.10.1, which will get me to hopefully anywhere. But if I knew for a fact that there's another router on my network, and that router is specifically connected to the 192.168.11 network, then I could send packets there. So I could say 192.168.10, right? That's the network I'm on. We'll say .2, okay? Maybe that's the IP address of a router that's connected to the 11 network. Now watch what happens when I hit enter. I intentionally did something here, and we're going to get an error. You'll see here it says the requested operation requires elevation. We've seen this before when looking at other command line tools. What that means is I have to close my command prompt window, and this time when I open it, I have to right-click and run as administrator. Now I can do that command again. First of all, I'm going to do route print just to show you it's the same, right? I didn't change anything. But now I'm going to do the route add. I'll do this quickly now, 192.168.11.0. Put in a mask of 255.255.255.0, and we're going to send it to 192.168.10.2. When I hit enter, it says OK. And I love that it says OK, because so many commands just bring you back to a command prompt and you're scratching your head going, well, did that actually work? Well, here it says OK. Love it. To verify that it truly is OK and it's been entered, we're going to do route print. And this time you'll notice that I have another entry here that I didn't have before. It says that if I'm going to 192.168.11.0 with a 255.0, right? So if I'm looking to send something to that network, send it to 192.168.10.2. And you'll notice the interface auto-populated itself to, well, the one interface that I have, and it auto-generated itself an appropriate metric. So that just kind of gives you an idea of what these routing tables can look like. And if we were looking at the routing table of an enterprise-level router that was connected to many different networks, you would see all sorts of different entries here for all the various networks and exactly how we would be routing to those networks. Now, we're going to talk in a little bit about how these routing tables get updated and things like that. But for right now, I just wanted you to see that. Now, the one other command I want to show you is the route delete command. Because I'm going to hit route delete and put in 192.168.11.0. That's all I need. It assumes everything else. I hit enter. It tells me OK. I do route print. And sure enough, that entry is gone. Now, another way I could have had that entry be removed would have been to reboot the computer. And the reason is because I didn't do the -p command. So if you ever want an entry to be put into your system and kept there as persistent, meaning it stays until you eliminate it manually, then you got to do the -p command. So that's pretty much how the route command works. So now when it comes to routing tables being updated, okay, or we could say being configured, there's two different ways of looking at it. There's two different approaches. There's what's called static routing, and there's what's called dynamic routing. And it's pretty much what you kind of think it would be, in the sense that static routing means that the routers are going to have their routing tables configured and updated manually, meaning you literally have to go in there and modify, well, and I shouldn't even just say modify. You start off configuring those routing tables on a router, and then when there's a change that needs to be made, you go in there and modify them. Whereas dynamic routing is where routers can communicate with each other and share their routing information with each other and get their routing tables updated, you guessed it, dynamically. Now, another thing that you may have figured out is that static routing is, well, kind of a thing of the past, right? And you might be thinking, well, why would you ever want to do it? Well, you don't. It's the way we used to have to do things. Whereas now, it is more typical to use dynamic routing. Now, for that reason, I want to make sure that you understand truly what I mean by dynamic routing and understand how that actually works. So I have a little demonstration that I've put together here for you, something a little fun thing that I've done over the years, and I hope you enjoy it. So here it is. Hi, I'm a router, and I'm attached to network A over here and network B over here. Now, I've been pre-configured with this information, but that's all I know right now. So, like I was saying to you before, a router will have some pre-configured information just by being turned on. Or in other words, if I'm a router and you turn me on and I'm connected to these two networks, I'm going to know about network A and network B, and I'll have a basic routing table up here that says, all right, I know about A and B, and A's over on this side, and B's over on this side. Okay, so that's our starting point. But then, hi there, I'm a router too. I not only know about network A, but on the other side of me, I'm connected to network C. Okay, and just like with the first router, the second router is aware of networks A and C and has had that pre-configured. Great. I'll keep that in mind if anyone over here is looking for network C. So what I've done here is I've made an entry into my routing table that says if anyone's looking for network C, see, I don't know where network C is, but what I do know is that I can send it to this other router over here, okay, and it's going to go out through network A. So through network A, I can get to network C, and it's going to be one hop. Now, what does that mean, one hop? A hop means the number of routers that the data is going to have to travel before it can get to its final destination. Or if you've ever heard the term next hop, that means the next hop is whatever the next hop in line is if you have multiple hops, or the router next to me. All right, so going back to the demonstration. Hey, as long as we're sharing information, did you know that I'm also connected to network B? No, I didn't know that, but I'll make a note for future reference. Okay, and so now as you can see, this other router has gone ahead and made an entry that says if anyone is looking for network B, well, it's going to be a router that's connected to network A, which I'm also connected to, and again, it will be one hop. Oh, look, there's another router coming into the picture. Hello, I'm also a router. Not only am I connected to network B, but the other side of me is connected to networks D and E. And so once again, you can see that this router has been pre-configured with a routing table that shows B, D, and E. Okay, so it's not just two networks that get set up. It could be three networks if that's what the router is connected to. Awesome. I will keep that in mind if anyone over here is looking for those networks. So now in the routing table of the first router, not only do we know about network C, which would be connected to another router off network A, But we now know about networks D and E, which are connected to a router off network B. Hey, and as long as we're sharing information, did you know that I'm also connected to network A? Hey, that is good to know. And as you can see, routing tables are being updated. And here's something really cool. On the other side of network A is another router. No way! Yes way. And that router is also connected to network C. Cool, I'll update my information. Well, look what happened here. This router has now made an entry that says in order to get to network C, so in other words, if that router gets any packets that are destined for network C, I know that I need to send it to another router which is connected to network B, and I know that's going to be 2 hops now before we get to our final destination. Okay, and this is because it's going to have to go through the middle router first, and that's 1 hop, and then the next router, which would be the 2nd hop, before it can get out to network C. Hey you, the router over on network A. I just found out about another router on network B. Yeah, so what? Well, that router is also connected to networks D and E. I just thought you might want to know. Hey, that is good information. Thanks. And as you can see here, this router has now added D and E, each being 2 hops and each going out through another router connected to network A. And now all 3 routers are completely aware of all 5 networks, right? So if we look at any one of these 3 routers' routing tables, we will see the letters A, B, C, D, and E. So in other words, there will either be a network that router is specifically connected to, which would be these entries up here, or we'll know exactly where to send the packets off to and what network it needs to be sent out on in order to get there. And because I pretty much told this demonstration like a story, we have to have a happily ever after. The end. So now that you've seen how dynamic routing works, I need to explain to you that that's just kind of like a concept on how it works. The reality is that you need to have a routing protocol to give the actual rules and procedures for how the routers are going to specifically communicate with one another to get these routing tables updated. And there are 2 different styles of routing protocols. There are distant vector routing protocols, and this is where each router communicates all of the networks that it knows about to all of the other routers to which it is directly attached. And when using this type of routing protocol, communication typically will take place on some kind of a regular or scheduled basis. Whereas another type of routing protocol would be something called link state routing protocols. And this is where each router will build a map of the entire network. There is something called link state advertisements, or LSAs, that are then used to communicate the information about all the networks that they are connected to. And in this case, communication only takes place when a change has actually been made. Okay, so that's kind of the difference here on the type of routing protocol that we're using. So now I want to talk to you about some of the specific protocols. And I will tell you that these are going to be kind of high-level overviews of some of the common protocols that are used out there. And I will tell you there's definitely more information when it comes to actually configuring these protocols. But for right now, I want you just to be aware of the types of routing protocols that are out there. Now, the first ones that I want to go through with you are distant vector type routing protocols. Okay, and the first one is called RIP, or RIP, which stands for the Routing Information Protocol. Now, besides telling you that it is a distant vector protocol, I will tell you that it supports a maximum of 15 hops. Okay, so when we talked about the hop count when we went through the demonstration, RIP can only support a maximum of 15 hops. Originally, it has updates sent every 30 seconds. It does not support authentication, and it uses broadcast communication. So if you think about it, when we used, and I will tell you, if you haven't figured out, this is somewhat of an out-of-date protocol. When using just standard RIP, you're creating a lot of network traffic just with the routers trying to update each other. Okay, it won't work with that large of a network because you can have a maximum of 15 hops. Every 30 seconds, by default, originally, it has updates being sent out from each router to all the neighboring routers. Every 30, and it's using broadcast communication. So what that means is, even though it's communicating with the router next to it, it's doing it in the form of a broadcast. So every single device on the networks that those routers are connected to has to put up with this broadcast going out every 30 seconds. So what they did to help with this is they moved to RIP version 2. Now we still have a maximum of 15 hops, so we're not talking about very large networks here, but it now supports authentication, which helps, okay? It helps with making sure that you're not just communicating to any old router, but you can authenticate. But we also, and this is probably I think where it really gained popularity, is it used multicast communication rather than broadcast. So that way you can have just all the routers subscribing to the multicast and not having all the various clients on the network having to be bothered with the update information. Now there is one more here called the Border Gateway Protocol, or BGP. And I will tell you that this is the core routing protocol of the internet. Now what that means is it's not something that you're typically going to be using in-house. It's the routing protocol that is typically used by your ISPs, or your internet service providers. Now if we move on to our link state protocols, I will tell you that there's really only one that we really need to talk about. I'm actually going to tell you about two, just to make sure that you're familiar with this other one. But let's talk about the first one here, and it's OSPF, and that stands for Open Shortest Path First. This is the type of routing protocol that would be used in more of your medium to large networks. It does base its paths off link states, right? Because we talked about this being a link state protocol. And it can also use cost metrics to give preference to certain paths. Now, I don't have it listed here, but I will tell you, OSPF is much more difficult to originally set up and configure, and it kind of makes sense that it would be, whereas the RIP type protocols were very easy to set up and configure. But the trade-off is that it works very well for your larger enterprise-based networks. It's very scalable and it can grow very easily. And once it's up and running and in place, it's very easily managed, not only from an administrative perspective, but from a data flow perspective. Because again, the only time that you're really going to be having updates traveling around the network is when there is some kind of change. Okay, because that would be crazy having all those updates going across the network on a regularly scheduled basis in a large enterprise environment where there's a lot of routers. Now, as I mentioned, there is a second link state protocol that I'm just going to kind of quickly go over with you, and it's IS-IS, which basically says intermediate system to intermediate system. That's what that stands for. And I'll tell you that where it got its name from is, well, intermediate system sometimes is considered to be another name for a router. So it's kind of a simple way of saying we have a protocol called router to router. Well, that kind of makes sense if it's a routing protocol, right? This is a protocol that was originally designed to work with the OSI, and I actually have it listed here with the OSI model, but really what I should say is it was originally designed to work with the OSI protocol. Okay, and this is a protocol that was designed, well, strictly off of the OSI model, and it's a protocol that's not heavily used. Therefore, it's not a protocol that's heavily used, but I wanted to make sure that you were familiar with it. Now, I mentioned that there are just the two types of protocols, right? There's the distant vector and there's the link state. But the reality is that there's also a hybrid version of those two types of protocols. And there's really only one main type of hybrid protocol that I want to talk about, and that's EIGRP, which stands for the Enhanced Interior Gateway Routing Protocol. I don't want you to get hung up on this. I will tell you that primarily what you would be working with in most environments would be either RIP, or more specifically in today's world, RIP version 2 or OSPF. But I want to make sure that you've at least heard of this protocol here. And here are just some real basic pieces of information about how it works. First of all, it evolved from IGRP, which is just simply the interior gateway routing protocol. That's the older version. Now we have the enhanced version. It uses something called the diffusing update algorithm, or DUAL. Each router keeps a copy of its neighbor's routing tables, and each router will periodically send out a hello packet to keep track of the state of its neighbors, right? So it checks to see if the neighbors are currently in an up or down state. So as you can kind of see here, it is kind of a hybrid of how distant vector and link state work. Now, the last thing when it comes to talking about these routing protocols is there's a couple terms I want you to be familiar with. And those are IGP and EGP. An IGP protocol is an interior gateway protocol versus EGP is an exterior gateway protocol. And what does that mean? Well, if it's an interior protocol, it means that it's used to exchange information between routers within the LAN, or within the interior, as opposed to the exterior protocol, which means it's a protocol which is used to route information outside of the local network or through the exterior. And most typically, that would mean out to the internet. Okay, so I just want you to be familiar with what those two terms mean. So now there's one last term that I want you to be familiar with when it comes to understanding routing. And that term is convergence. See, now here's the deal. When changes are made to a network, every router on the network is going to need to make an appropriate update to their routing table in order to accommodate whatever that change was. Now, when I say change, that could be the addition of a new router, right? We saw that in the demonstration that I gave of dynamic routing. Or it could be the deletion of a router. Or maybe it's just some kind of a change in the metrics or the paths as far as how data is going to travel around your network. Whatever the change is, remember, all routers have to have some kind of change, potentially, to their routing table in order for things to work. So convergence is the process of all routers becoming aware of changes to the network. So as we added routers in the demo that I did a little while ago, the dynamic routing demo, when I got to the very end, when I pointed out that you could now go to all 3 routers and they would all know about all 5 networks, that means that convergence had completely taken place. Okay? Updates have been made to all routers about all networks. So that does bring us to the end of this lesson. And this is, I know it's one that you've been waiting for because we talk about routing a whole lot throughout the course. Hopefully this all makes a lot more sense to you. And that said, I'll see you in the next lesson.